Hi, I'm James Mullenbach, and I'm going to present our work on knowledge-based completion for constructing problem-oriented medical records done with my colleagues at ASAP. So there's this problem in healthcare that was once called death by a thousand clicks, wherein a physician often spends more time interacting with their EHR software than with their patients. Part of the problem is that they spend a lot of time clicking around to find patient data relevant to their decision making in source oriented records, when data could instead be oriented around health problems, as first suggested half a century ago by Lawrence Weed. I'll explain what I mean by source oriented by example. So imagine you're a physician treating a patient with atrial fibrillation and irregular heartbeat, and you want to determine if the dosage of their blood thinner is appropriate. In a typical source oriented record of today, as in this mock up, you'd have to navigate the different sources of data via this menu on the left to find medications. Then you have to dig through their medication history to find the dosage, make a mental note of it, go back to the menu, click on all results to look at their lab results and find their clotting parameters, and then keep the dosage in mind to make a decision. So instead of all that clicking and searching, we can instead orient the data around the problem itself of atrial fibrillation and show the medications, procedures, and lab results all underneath the problem heading. And we can do this for all the patient's health problems. So, as a technical challenge, we have to determine how to actually associate the relevant medications, procedures, and labs with the problems. We could use relations in UMLS or other ontologies, but those are always incomplete. Embeddings might bake these relationships in, and we find that they're useful, but they're not enough. So we take the approach of treating this data as a knowledge graph or knowledge base to be completed, which we know we can train machine learning models to do. To construct the starting graph, we define 32 problems that are common in our dataset and annotate several dozen medications, labs, and procedures for each of those. We train a Dismalt model, which was previously introduced for general knowledge base completion, which computes a three-way dot product of problem, relation, and target embeddings. And we train this with our annotations, which hopefully includes negative examples. For experiments, we compare using embeddings trained internally to a site or site-specific embeddings compared to external open source embeddings trained on larger data. And we compare on the mean reciprocal rank and hits at 5 of ranking. And the external open source embeddings turn out a little bit better just using them out of the box. When we use them to initialize the Dismalt model and train that, we get a bit of a boost. And then using engineered features on top of that, again, provides a boost. Here's some example outputs from our best performing model on the problem of sleep apnea, which is not seen at training time. And there's a separate set of results in the paper that show that we can use KNN to improve initialization. Thanks, that's it. All of our code and data is open source. Happy to take questions at the poster session.